Sir, let's begin then. Sir Mahadevan sir. Can you join in? Okay. So I'll just this. So good evening, everyone. So I welcome all of you to this web program, Celebrations of World Water Day. And I invite Professor Lakshmi Suresh to offer the welcome address.
Thank you, Bindu ma'am. Good evening, all. Conservation of water resources and its judicious use is a primary concern today. On this context, Ahalia School of Engineering and Technology is hosting a session on water conservation and its practical use. First, I would like to invite Dr. P.R. Mahadevan Pillai sir, Principal, Ahalia School of Engineering and Technology, and Director Academics, Ahalia Group of Institutions. Welcome you, sir. I would like to invite Dr. Krishna Kumar Kishore, Vice Principal, Ahalia School of Engineering and Technology, and Executive Director, Ahalia Group of Academic Institutions. Welcome you, sir. Next, I would like to welcome Dr. G. Muruganand, Secretary, ISTE Ahalia Chapter, Coordinator, ISTE IIC for this program. Welcome you, sir. Also, I would like to welcome Dr. Mahima Ganeshan, President of IIC for this program, who's proposing the vote of thanks. Next, I would like to welcome all my colleagues and students to this session. Welcome you all. Last but not the least, I would like to invite all the external participants for this session. Welcome you all. Thank you.
Thank you, Lakshmi ma'am. Now I invite Dr. Muruganand G, Secretary, ISTE Ahalia Chapter and Coordinator, ISTE IIC for his initial address.
Good evening all. Is it audible, ma'am?
Yes, sir, you're audible. Yes.
Okay, thank you. So, respected dignitaries, Dr. P.R. Mahadevan Pillai, Principal, ISTE, and the Director, Ahalia Group of Institutions, the Chief Guest of the day, the opt guest for this wonderful occasion where we are going to celebrate the World Water Day 2022 with the theme of groundwater making the invisible visible. So happy evening to all the participants, all my colleagues, the chief guest, Mahadevan sir, all of you. So I am happy to deliver the presidential address for this Tech Talk series with the theme on water conservation and groundwater making the invisible visible. So let me start with quoting something from Tirukkural. நீரின்றி அமையாது உலகினின் யார் யார்க்கும் வான் என்று அமையாது ஒழுக்கு. This is, hope you all know about Tirukkural. So what exactly it says is, Tiruvallur means over here is, whoever may be in the world, anybody in this world, any human being, any living being in this world can exist in this world without gold, silver, or any prosperity of the life. But none of the beings, living beings in this world cannot exist even a single day without water. So water is a basic need for all the living beings in the planet Earth. This is very, very essential for us. How do we get this water? The main source of water is rain. That's why in this Kural, Tiruvallur is addressing rain as a god, a symbol of extension of God. So if there is no God, what will happen? Or if there is no rain, the whole economy of the world will go down. It will spoil the complete agricultural system. The poverty increases, all sort of indisciplinary activities increases. It will spoil the environmental decorum. So ultimately, it will turn the entire world into destruction. So what will be the impact? The final impact is the world will perish. So being a human being, we need to preserve water. There are certain reasons why World War III will be expected. The main reason is it is water, followed by air and food. So very soon it is going to happen. Obviously, the circumstances going in and around this is a very good evidence for it. Particularly those who are attending this meeting, we, the citizens of India, should not forget 19th June 2019. Why? What is the importance of the day? The reason is that was the day in which Chennai city was declared as zero water day. Not only that, dear friends and colleagues, 16th April to 11th May 2018, for this entire span, the Cape Town, the primary South African country, city, was declared as zero water days. So we should not forget all these days. Right? See, whenever you are feeling thirsty, a small drop of water will make you feel like an elixir. There may be many reasons for this zero water days. The main, most important reason is cutting the trees and deforestation. We have numerous examples that can be illustrated. For example, I am hailing from Pollachi. So in the year 2015, I used to travel from Pollachi to Coimbatore in a two-wheeler. I used to enjoy the riding because all the roads will be covered with full of trees. But now, very recently, when I ride a two-wheeler from Pollachi to Coimbatore, I felt like entering into a furnace. Why? Because in order to expand the road, all the trees available on the shoulders of the road have been completely removed. So I could feel the heat. It was like entering into a furnace, traveling inside a furnace. Right? So who is responsible for all these things? We the people, we the human beings, we are making our life so much of sophistication, wherein we are not balancing a proper ecosystem. So because of this, we are getting zero water days. So how to overcome all these things? The answer is very simple. Every individual, let us take a oath on this day, let us plant a tree. You all can say, okay, just planting a tree may not be, everybody can plant a tree, but mere planting a tree will not be sufficient. Why? Because being an energy assessor, in the verbs of energy audit, we say that we have to monitor, verify, and also follow up whatever the action plans we suggest. That is a duty of every auditor. So being an energy assessor and an auditor, I also request you all not only to plant the trees, but also ensure that we water the trees properly so that we get more rain, sufficient number of rain, and thereby all these days will be overcome. Friends, before concluding, I would like to suggest you to go with the 3 R's. All of you may be knowing it, but still try to reduce the consumption of the water, try to reuse the water, whatever is available. Many good examples are nowadays being practiced by Japanese people. We can incorporate those examples over here in our life and also try to recycle. In these ways, we can conserve water, right? So when we implement all these things, certainly the theme of this day, that is making the groundwater invisible to visible, will happen very soon. So with this small speech, I extend my sincere thanks to the organizing committee for the opportunity to preside over the program. Wishing you all a very happy World Water Day. Conserve water for the better tomorrow. Thank you all.
Thank you, Muruganan sir. Now, Jolsna, you please take the program forward from here.
Now, I would like to welcome Dr. P.R. Mahadevan Pillai sir, Principal, Ahalia School of Engineering and Technology, to give over the inaugural address and keynote address.
Thank you, Jolsna. Am I audible?
Yes, sir.
Okay. So before I start presenting my PPT, I'll have some words of wisdom to ponder over. Firstly, today is the World Water Day. For the last 23 days, that is starting from March 22nd, 2000 to March 22nd, 2022, 23 days we observed as World Water Day. So this is the 23rd World Water Day. It's for spreading message on conserving water. Every year, UNESCO, United Nations Educational, Scientific and Cultural Organization, to choose a theme for World Water Day and conduct discussion all over the 193 UN member countries on conserving water, preserving water, keeping water intact, because water is a huge concern. Why water is a concern is 70% of the earth is covered with water, but only 3.9% of that water is fresh water. Remaining 97 or 96.1% is not fresh water, it is saline water. So it is just like the poem in Mariner's Rhyme by Samuel Taylor Coleridge. Water, water everywhere, nor any drop to drink. Water, water everywhere, and all the boats did shrink. So water is plenty, but not potable, not drinking water. And funnily enough, out of this 3.9% water which is fresh water, only 3% of that is available to the human beings for consumption. So if you take out of the total water available, it is only around 0.12% of the total water that is available to us for drinking. Last year, the estimate was that there are around 300 crores of people who don't have sufficient drinking water. And there are more than 220 crores of people who have no access to good drinking water. Sufficient and access are different. That means 1/4 of the population of the world is water starved. They don't get good water, and because of that, they have got waterborne diseases. You know that waterborne diseases and water pollution are two major concerns, which I'm not going to address right now because that is another topic. So water is a very precious element. There is an old saying that a person can survive without air for 7 minutes, without water for 7 days, and without food for 7 weeks. It's a rough estimate. Some people can live even more. But even then, dehydration will take place in your body if you are starved of water for 7 days or more. So water is an essential life liquid. Your blood is water, your body is around majority of the body part is water, and water is the one which circulates your blood inside your body and circulates the lymph, even the used blood inside your body. So water is a sine qua non for life on earth. And the first life started on water, and even today, life is sustained by water. That is the importance of water. So to spread this message to all the people, all the continents, United Nations devised this particular day, World Water Day. So today, every year they have got a specific theme. Today's theme, we will start with that. I'm going to present that theme today. Then we will see. On the right side of this, you can see it. Can you see my slide? Yes or
Yes,
no?
sir. Yes, it's visible. Yes, it's visible.
Okay. Yes. On the right side of my screen, you can see the motto for this year's World Water Day. Making the visible invisible. Sorry, making the invisible visible. What is invisible? The water which is hidden to us, which we cannot see directly, is the invisible. So as far as water is concerned, the invisible part is the water below the ground level, which we call as the groundwater or subsurface water. The visible water is the water above the surface, which is visible. Funnily enough, only around 1 to 2% of the water is invisible. That is, of the total water available on earth, only 1 to 2% based on the locality is invisible. But that 1 to 2% is the drinking water for 95% of the population. See, only 5 to 10% of the population can depend on visible water. Visible water mostly we get from rivers. We cannot take visible water from the seas. Only the river water or very rarely the lake water, because most of the lakes in the world are saline water. Or even if it was not saline, it had got saline intrusion and it has become non-potable water. So basically, we are surviving, most of us surviving with the groundwater. Luckily, in Palakkad and nearby places, we are surviving with surface water because Malampida Reservoir, which is the biggest reservoir in Kerala for drinking water purpose. Obviously, by the volume, if you take it is Idukki, but for the drinking water purpose, the biggest contributing reservoir in Kerala is Malampida, which is providing drinking water to around 4 to 5 lakhs of people in rural area and around 10 to 15 lakhs of people in urban area. So it's a big catchment area for drinking water. Though Malampida was designed as an irrigation reservoir, it is now mostly serving as a drinking water reservoir. So this is this year's topic, making the invisible visible. That means making the groundwater known to us. How to preserve the groundwater? What is the necessity of preserving it? Making it known to the public is the meaning of making the invisible visible. That is why for this talk today, I have chosen the topic water conservation practical aspects. Practical aspects in the sense it's not an imaginative plane which I am talking. I've been associated with water conservation activities for the last 4 decades. So many of the things which I am telling will be based on my experience rather than theoretical knowledge. Obviously, theory also has to be supplemented. So let us see what are the things which we are going to discuss today. This is what is called the water cycle, which anybody would have learned in the school days. Water from the seas will evaporate. Not only sea, any water body, the water will evaporate. Even from Malampida Reservoir, annually 24 to 25% of the water evaporates. That means it goes back to the atmosphere as vapor, water vapor. That evaporated vapor will go up in the clouds and the clouds will cool and condense. Condensation is a process where the minute particles of the water vapor will surround a solid particle called nucleus and they become what is called water drops. These water drops make what is called clouds, and the clouds, when they precipitate, precipitation is nothing but rain. When they precipitate, they come down to the ground surface, and from the ground surface there are two parts for the water. One is called the runoff water and the other is called the percolation water. The runoff water goes running. That is why it is called runoff. It goes via streams and rivers and ultimately it joins back the sea. Whereas the groundwater goes down the ground and slowly it moves in the ground. It's not stationary in the ground. Very slowly it moves along the slope. That rate of movement I will be explaining to you very slowly. But it keeps a surface below the soil which is called the groundwater table, GWT. GWT depends on the surface of the earth. For example, we may think that GWT is a horizontal line or horizontal layer. No. Even on a hill, groundwater table will be there because the groundwater, by a peculiar action of the earth which is called capillarity, the groundwater table at a higher location will be higher based on the surface of the earth. Only thing is the depth of the groundwater at different places may depend on the porosity of the soil at that area. So groundwater, where it is available, how deep it is available, depends on the nature of the soil in that area. If it is pure rock formation, groundwater may not be available, but we will have something what is called underground water. Underground water will be something which are stored in locations called aquifers. We will discuss what is that. So again, this groundwater will flow slowly to the water streams like rivers and it will reach the sea. So groundwater is not a stable platform. It will again flow, which many of us are not concerned about. Groundwater will also flow, but the flow is very slow. So there are different processes in this. First process is evaporation. Second process is evapotranspiration, where the breathing plants evaporate water. That is called evapotranspiration. Then condensation happens in the cloud and it leads to what is called precipitation. Precipitation, different types of precipitations are there. The most common in Kerala is called cold front precipitation and orographic precipitation. Cold front precipitation is mostly caused by the trees which are there in our land. There are different forms, reasons for precipitation, for rain. The most common in Kerala are orographic and cold front. Orographic means the hills stop the cloud and rain. Cold front comes because there is a cold temperature generated mostly by the plants below, and that temperature will condense the clouds. Anyway, ultimately, it goes to the ground, and that which goes below the ground is called the infiltration or percolation. That which goes runoff, it will form the ponds, lakes, rivers, etc., etc. And groundwater, obviously, is only a small part of the precipitation. Of the rainwater, only a small part is what is the groundwater. And then where the soil is very porous, if, especially in the forest areas, the soil will have a spongy top, which is called like a sponge, similar to spongy top. That is called a humus. This humus can collect, like the sponge does, excessive water. It can store a huge quantum of water. The sponge can collect. Whereas in dense soil like laterite or heavy formations or clay, where the porosity is very less, the water storage will be very less. So the quantum of water availability will depend on the soil below. But below the ground level, sometimes below the rock formation, sometimes soil deposit will be there. And many places there will be degraded soil which is below the rock formation. Such formations are called aquifer. Aquifer basically means a place where water is stored. Aqua means water. Aquifer means a layer where water is stored. That layer may be below the top surface. That is where you get the borewell water from. Borewell normally you don't get from the surface. Many borewell you have to go 20 feet, 50 feet, 100 feet, 200 feet, etc. If it is 200 or 300 feet, quite naturally, that will be taken from below the rock. Below the rock means, say for example, here you can see in the figure, different layers of rock. And below one layer of rock, there is one layer of loose soil. Such a layer which is below the rock level, one layer of rock, is called an artesian aquifer. Artesian aquifer means the water in an aquifer which is an artesian aquifer. Artesian aquifer means below the rock. Again below that rock, again rock, below that aquifer, again rock can be there. Even below that soil may be there. In some places by exploration we have found that 3-4 layers of aquifers are available even within 500 feet. Recently, I have done an exploration at a site in the hilly area of Palakkad district, Attapadi region, and I found that there are 3 layers of aquifers available below the rock. It may be separated by 10 or 15 meters like that. When you go for a deep digging, either for well purpose or for exploration purpose, you will come across these layers. And many of these layers will have abundant storage of water. For example, Plachimada is one area in Palakkad district where there was a deep aquifer which was not accessible to the local public, and it needed a deep well. And that water to the aquifer will be entering from kilometers away. You see here in this figure, you can see one place in the right side which is called recharge area for artesian well. Recharge area may not be where you are taking the well. For example, this well is here, but the recharge area is here. This may be sometimes kilometers apart. The plate tectonics of the earth is such that the plates may extend to so many kilometers. For example, the plates which are originating from Coimbatore area are running below Ahalia campus also. That is why it's a tectonic plate. It is bound to earthquake. So the area which we are situated, only thing is there is no history of heavy earthquake. The earthquake which has occurred there was below Richter scale 3. So there is no risk of heavy quake. But it's a tectonic area where earthquakes, minor tremors are possible. A minor tremor is possible in many parts of Kerala. Okay, that I am not discussing right now. So the rock above the aquifer and below the aquifer will be normally impervious. They are called acutad, means that which stops the flow of water. Retard, retard is called acutad. So this is how the groundwater is. Now you got an idea about what is the groundwater. Now this is our fate now. This photo was taken from Plachimada when the Plachimada struggle was going on in 2004 or 5. This was taken by a press photographer. I got it from him only. Because you know that I wrote a book on Plachimada. This photo I reproduced in that book. This was the real situation at Plachimada then. How many years back? 2004 or 5, I think. So around 16, 17. This is the fate now. We have got a dried up surface. First, we should have water on the surface. Then we should have water on the subsurface. Now, to avoid the risk of losing the drinking water, we can perpetually store water underground. Many people don't know this. We can store water underground, even in the earth. There are techniques for that. Those techniques are called groundwater recharge. How you can put water into if there is an aquifer, it's well and good because the aquifer will store water for a long time. So if there is an aquifer, especially a perched aquifer or a deep aquifer or an artisan aquifer, the advantage there is that even in artisan aquifer, you will have a large storage capacity. As I told, sometimes the area of the aquifer will be even kilometers. So if you can let the water go and store there, that can be used by deep wells, deep bore wells. But not even that, even in your own land, your own household, you are wasting the water because you know that out of the water which is falling by rain on your land, only 25% infiltrate. Remaining 75% is running away. That's called runoff. So this 25% you can increase to 50%. How? You make your surface uneven by digging here and there. So in your plot of land, suppose you are having 10 cents plot of land. You are having, say, a 2 cents full of house. If you are having an 800 square feet house, approximately 2 cents full of house. 880 is roughly 2 cents. So 2 cents may be full of house. Remaining 8 cents, there is no house. So in that 8 cent, if you dig ditches, small ditches of any size, water will collect in that and it will go into the ground. What is advantage is your groundwater table will increase there. Otherwise, that water will flow away to your nearby road or canal or sump, whatever it is, and you are losing it. Water is your resource. The water which falls on your land. Take for example in Palakkad district, earlier the rains were very less. Rains were very less means in 1 square meter, we used to get only 1.2 meter cube of rain. 1.2 meter cube means 1200 liters. This was roughly the estimate long back. Now in Palakkad, every square meter, we get around 2000 to 2200 liters of water. And suppose you are having 10 cents of land. 10 cents of land will be around 440 square meter, roughly. Yes, around 440 square meter, you multiply by 440, you multiply by 2000. That is your own water in Palakkad on an average, especially in Kanchikode area, especially in Ahalia area, which is a rain shadow area. This 2000 may be a bit less, but for the last 2 years, we have been getting more than 2000. The rain in Ahalia area also had been around 2400 millimeter rain. That means every square meter you get around 2.4 cubic meter water. Each cubic meter is 1000 liters. So multiply 2400 by the Ahalia area in thousands of square meters. Ahalia area is in lakhs and millions of square meters. That is the area you get. Even in Ahalia campus, where we are conserving the water, we are tapping the rainwater, we are able to store around 2 lakhs liters of water. 2000 lakhs liters of water, not 2 lakhs, 2000 lakhs liters of water. That will be enough for us for around 2.5 years for use. We are using lavishly. Controlled use, but even there we are not conserving 100% because of the terrain difficulty. So if we can conserve the water 100%, because some of our water is going by percolation. In all our 10 lakes together, we are able to store only 2000 lakhs of liters only. And in a place like Ahalia, on a day, 2 to 3 lakhs liters of water will be required because, so many institutions, 8 colleges, 2 schools, big hospitals, all other establishments, even medicine manufacturing unit, we need a lot of water. But in a small household, even in a single cottage, we are having hundreds of cottages there. Even in a single cottage, the water consumption may be around 1000 liters a day. That means even if you take 100 quarters alone, the water consumption in a day may be around 100 into 1000, maybe around 1000 liters. That is why I'm saying Though we are storing around 2 lakhs liters of water, I don't feel that it is quite huge. But at your household, say for example, I am staying in a house where the land area is 20 cents. My house land area, I purchased a plot of 20 cents and built the house here. All the rainwater falling on this 2000, this 20 cents. 20 cents means multiply by 40.4. That means square meters. Each cent is 40.4 square meters. So around 880 square meters I am having. Multiply 880 by, here the rain is around 2.2 last year, 2.2 meters. That means 2200 millimeters. So multiply 880 by 2.2 into 1000. That much liters of water I am getting in my house plot itself. That will be enough to supply me drinking water for around 5 to 6 years. But I am not tapping it because conveniently I am having a well with me, and Malambida water supply is also there. So since two sources are there, but I am doing something so that most of the water goes down on my land itself. Everywhere I am blocking it so that it goes down in my own land. So the well is recharged. So those who are having open well at your home, please ensure that the well itself will be a small round, but you make the soil to absorb that water instead of letting it go away. So that is the simplest rainwater harvesting device, making ditches and big holes in the ground. Very, very cost effective because you can use it for, even if you are using a waste dump sump, you are making a ditch for waste dumping, even that will percolate the water to your ground. Only thing is that will have some vegetable debris or something attached to the water. But it is better to have separate small sump. It need not be 1 meter by 1 meter size. It can be even 1 foot by 1 foot. If even that is not possible, because to make such ditches you need a labor. You can make small ditches where the water will store for 5 minutes and will go down. By the time the rain is happening, so many liters, even a small ditch of 1 foot by 1 foot will be able to percolate around 1000 liters of water in a rain. See, very simple, because on the top surface, the water will spread immediately. When it goes down and down, the water movement is very slow. Another method, of course, this is another method for storing the runoff. This is somewhere in Palakkad, you know it. This is a check dam, which I always remember because the entire work for this check dam was done by myself and my students. This is the first storage check dam in Palakkad, in Paradapuzha. This is at Lekkadi, near Lekkadi railway station. This was a government funded project. The superintendent engineer at that time, he was a water lover, TNN Bhattadiripat. I always remember, he requested, why can't we construct some check dams in Paradapuzha? Can you provide us some project report so that I can take the fund from the, apply for the fund from the water mission? It was in the early 90s, late 80s, I think. So I said, okay, definitely, I'll come with my students who are doing project work and we will make report. We made report for 4 check dams, one at Lekkadi, one at Parli, one at Andimadam, and one in between Parli and Andimadam. Out of those 4 proposals which we submitted, 3 were constructed. This is one among them, which is the Lekkadi check dam. This was the first one which was constructed. And I had a very happy occasion recently. The students who did this project work with me, we have been there many times to make the entire contour survey, to calculate the volume of water which can be stored, to see how much will be the seepage onto the sides and what much will be the groundwater improvement. All these things were studied in detail. And those who worked with me for this project, they came to meet me 2 years back, and all of them went. I didn't go. All of them went to this check dam, stood there and took a photograph and sent to me, saying that, sir, this is our check dam. And one of them already became a principal in a college at Ernakulam. So those people have got some affection to what they have done. So what I'm saying is, this check dam has changed the entire terrain there. That area was a drought prone area, but when the check dam came, the water level in the entire vicinity, the groundwater table went up. That is one advantage of the check dam. All the nearby locality, the groundwater table will rise. And this is a causeway type check dam. at all water comes over the check dam, it will flow freely. But shutters are also provided, but shutter will never be opened because that much pondage of water is always there. And we calculated the storage also. It was in some lakhs of liters. I don't exactly remember. That report I have to check. I am just saying that this is one method by which the runoff water can be stopped. When we were doing the study, one scientist from CFRI came, KERA, Kerala Engineering Research Institute, Pichi. He was a good friend of mine. He was saying that you are not letting the water to run. You are making it walk. True. A check dam will make the water to walk instead of run. And this is one example. This is a realistic example. And after the construction was over, many times I visited that. So worth seeing, because you feel a gratification that so many thousands of liters of water could be stored in a drought-prone area. And some families below the check dam, that is on the downstream side, were saying that they are losing the water. It's only a meaningless say because they are not losing any water. This check dam stores the excess water. It's not denying the downstream people any water. Any check dam is like that. So it's a misconception among the people that check dams to spoil the possibility of those who are downstream. And this I just wanted to, this is an experiment we started 23 years back. You know that I'm now working in Ahalia. Most of you are Ahalians. Way back in the late 90s, myself and chairman were walking in the Ahalia campus. Then all of a sudden, one worker came with a basket of clay. He said, "Sir, this looks very good clay." And I said, "Okay, you load onto my car dicky." He packed it, put it in a sack and put to my dicky. I brought to the NSS College of Engineering laboratory and I checked it. And I found that it is very good brick earth. Even better quality than the best brick earth available at Andimadam. Andimadam is the most famous place in Palakkad district where brick earth is available. And this was better than that. So I suggested that all this brick earth may be excavated. We make it brick. Then we will get a lot of, valley area there, just like lake. And that lake, we do treatment. We do use HDP sheet to cover it up. There are experts in that and make it all water conservation lake. And it worked. Now we have got 10 lakes. By the time the lakes were full, I was not here. I was deputed to Trivandrum. But I could see it every day. Nowadays, every day when I'm coming, I'm seeing the lake. So it gives me a lot of gratification that we could make these many lakes, big lakes, small lakes like that. And all the brick earth in that area, it was very good quality brick earth, have been burned to brick. Using the palmyra trees there, we burned it. There were so many rotten palmyra trees. The good ones we retained, the unusable ones or the dead ones we used as fuel for making this. So it was all a sustainable build-up. So this was how that area was there when we did the excavation work. When after the brick earth was removed, before the lake was made. But now, after the lake was made, after a good rain, it looked like this. See? And once later, in a fine spring, it was looking like this. Nowadays, we are not permitting boat because riding boat needs another license. So we are not permitting boats now. Now boats are being used by only the rapid action force, people who come there for training. Ahalia is not using boat because boat needs a trained person to accompany them. That because of that difficulty, we are not permitting it now. See the hospital in the background and the lake. So it's a beautiful site. This is a best example in Kerala of the water conservation which is done in a campus. And we Ahalians boast of this peculiar lakes because one of the best examples of water conservation. Otherwise, all this water would have been lost and we would have been a barren area, a barren land. And now we are having sufficient greenery. It is one of the greenest campus in Kerala because these lakes came up. And you see the plants which are around. Earlier in the 90s, we had only rotten plants and, ash-colored plants there because no water. Now all our plants are green because the lake did the miracle. This is the miracle the water conservation can bring. It will bring in another ecosystem. So this is something which all of us have to be aware of. Then another technique which you can do at household is rainwater harvesting. This I am telling the theory. I have not done it at my home. You know that in my home, whether it is in Trivandrum or Palakkad, I'm having sufficient water in the well. So I didn't think of this costly business, because if you have any difficulty of getting water from your well, then definitely think of going for rainwater harvesting. Rainwater harvesting, even your rooftop. Simply assume that you are having a 1,000 square foot house. 1,000 square foot house means roughly around 90 square meters. 90 square meters will give you at Palakkad 90 into 2, 180 cubic meter. That means 180,000 liters of water. If a family is using only 1,000 liters water, that 180,000 liters water is enough for them to substitute for to supply for the entire summer. The summer will be here around 6 months. In the rainy season, we already get natural water. Only in the summer we have to substitute with the stored water. Only thing is, storing the rainwater is a bit costly. You should have tanks. Tank is a bit costly, but even then, compared to the scarcity of water, tank is not that costly. There was a time when 1,000 liter tank was available at 1,000 rupees. But now 1,000 liter water tank will cost around 4,000 to 5,000 liters. For example, if you want, tanks are available in 1,000, 2,000, 5,000 up to 10,000. About 10,000 also you can make to order, but that is not required, because about 10,000 liters the tank will not be strong. 10,000 liters, up to 10,000 liters we get strong tank. Suppose you are having 10,000 liters, say 10 tanks, you can store water for 1 lakh liters. But 10,000 liters, 1 lakh liters storage will require around 4 to 5 lakhs rupees as cost of tank. But where water is very scarce, even that is affordable, because bringing water in a tanker is much more costly. 5,000 liters water, if you have to bring by a tanker, every trip, it will charge you around 2,000 rupees, every trip. So compared to that, in places where I know, when I was working at a college at Trivandrum, in the summer season, we had to bring water by tanker. We were having our own tanker. Even then, if you are having your own tanker, around 500 to 600 rupees minimum will be required for 5,000 liters. If you are hiring a tanker, it will be 2,000 plus rupees for a 5,000 liter tanker. So compared to that, storing water at home is advisable. So anybody who has got scarcity of water at home, I recommend to them, you please have rainwater harvesting at home. It is cheaper than any other method, even compared to bringing water. And so people in even remote areas, they can do. Everywhere in Kerala, obviously there is a boon to Kerala. It is God's own land. If you take on an average, the average rainwater in Rajasthan is much higher than us. You may not even believe. Rajasthan is supposed to be the desert area. If you take the average rainwater, when it used to be around 1,400 millimeter in Kerala, it used to be 1,500 plus in Rajasthan. Then there is water scarcity everywhere in Rajasthan, because in Rajasthan, the entire rain is focused on the spatial distribution of the rain is very less. The entire rain is focused in some areas, whereas most of the areas in the state are rain denied or desert areas. Kerala has got an advantage. Everywhere in Kerala, there is an even distribution of rain. And I don't know whether you are aware that the highest rainfall ever in India, the highest, when I was a student, we studied that the highest rainfall is in Cherrapunji, Assam. But that record was broken by Tirunelli in Wayanad district. Now the present record is the highest rainfall was in Tirunelli in Wayanad district. That was only for a day. If you take the average rain, Cherrapunji is much higher. Let it be. Cherrapunji at that time was in Assam. Now it is in Meghalaya. Anyway, that is not the question. I am saying that Kerala is blessed by one aspect. The average rainfall in Kerala is scattered almost even. Even the lowest place where rain shadow areas are there, we get around 1,000 millimeter plus. And the highest rainfall area, especially the Kuttanad area, the Idukki area, we get around 3,000 millimeter. But even the lowest rainfall, it never went below 1,000. Once or twice only it went up to 800, and the 800 millimeter means 80 centimeters. But last 3-4 years, the rainwater everywhere, the rain drop everywhere in Kerala was more than 2,000 millimeters. That means the entire rain you get in 1 year, you make it stand still at a place, it will be more than 2 meters. That means much more than your height. But it is going away. This is what I am asking you to store at your home if you have a scarcity of water. Rainwater harvesting is very simple. Very, very simple. Don't need any such diagrams to explain it. The rainwater harvesting is such that if you are having a roof, it is a tiled roof, have some wedge along its edges. You can cut the big pipes, plastic pipe, 4-inch or 6-inch pipe. You cut it and you keep at the edges of the sloping roof. That is one method. If it is an RCC roof, you will have water outlet of the RCC roof. That outlet you connect to a filter. Otherwise, the sloping roof, the water coming, you put a drainage pipe and that you connect to a small filter. A small filter is required. Small filter you can easily make. Take a 500 liters plastic tank. In that, you fill the filter material. Filter material will be, first layer will be fine sand, second layer will be coarse sand, third layer will be coarse aggregate like stone pieces or brick bars, etc. You fill it and let the water get into this and flow down from below. That water which is flowing down will be filtered water. That filtered water is very pure water because except the first rain, the rainwater is very pure. First rainwater, don't use it. So every water harvesting system has got a pipe such that the first rain, it will be just tilted away. It is not collected. Second rain onwards will be collected in the tank. Because first rain is highly acidic. That is why we say don't go out in the first rain. First rain is highly acidic. If it falls on your body, the first rain will put some marks on your body, which is not advisable. Acid, it's dilute acid. In places where the humidity is very less, like Los Angeles, it will be very concentrated acid. So standing outside, Kerala, luckily humidity is high, so we have the acids diluted in the atmosphere itself. So rainwater harvesting is only this much. Collect the water coming on the roof, pass it through a filter, a small tank filled with the filtering material, sand, coarse sand, and then gravel, and then broken stone pieces. This you can make for half a meter or even 1 meter, doesn't matter. A plastic tank will be 1.2 meters approximately. So even 1 meter is more than enough. Even 50 centimeters is enough. If you are ready to wash it once in a while, take it out, wash it, and then fill it. That is possible. And washing also, don't worry about whether all this will be mixed up, because you can have a sieve. You can sieve it and again put it back in the same order. It's not a big affair. You can do it already. So after that filtration, collect the water in either an underground tank, a masonry tank or concrete tank, or even plastic tank you can keep underground, so that the filter you can keep on the surface level. If you are keeping the plastic tank, storage tank on the ground level, the filter tank you can keep some 5 feet elevated by a stand or something. That is possible. Anyway, if anybody wants to make these things, I can give you the technical details. It is not that much costly compared to other methods of getting pure water. And remember, this is pure rainwater which you are getting. So rainwater harvesting is, these are the diagram for rainwater harvesting. In a Google Meet, it is very difficult to explain it. So I'm leaving it. If anybody wants to make a rainwater harvesting, come to me or contact anybody who is doing it. They will explain to you how it is done. Or simply, if there is a rainwater harvesting unit anywhere, you just go it and see it for 5 minutes. You will understand what is it. It's only that much. It's not a high-tech deal. So that is how we can have storing the rainwater without being run off. We are storing the water which is falling on the earth. So saving for the groundwater. The more rainwater you store, either on the ground or either as percolation or a separate rainwater harvesting, that much pressure less you are giving on the earth. Whenever you are giving pressure on the earth will react badly. For example, if you go to Plachimada now, which is very close to, there are 4 water-related issues which I am discussing here, which all came due to, Plachimada came due to excessive usage of groundwater. Parambikulam, Mullaperiyar and Adirapalli are issues of surface water. So I'll just discuss. My major portion was on groundwater, but I thought of, because these are the things which you hear a lot. Plachimada issue. Plachimada, even I have written a book on that. Parambikulam, Mullaperiyar, Adirapalli, etc. So I'll just have a glance on it. This is Plachimada area, around aerial distance around 20 kilometers from Ahalia campus. It's on the Meenakchipuram road, Pollachi road. I used to visit there many times when I was writing that book because I got a funded project to study about Plachimada. And this is the Geology of Palakkad district that I skipped now. But remember, you just see that Plachimada is in a high elevation area. And here in this diagram, what is marked with T is the Plachimada area. And you see that the Plachimada area, the mean sea level is 160 to 180 range in Plachimada area. This will be of interest to civil engineers. That's why I've shown. And this is the flow accumulation map. You just see that Plachimada doesn't have any river. Only rivulets are there. That is why Plachimada, the water replenishment is very less. Whatever rainwater falls there, either it goes down or it drains off immediately. You cannot harvest it back from the rain. And this is how the rainwater flows off. This we call the drainage network or the river network. Plachimada is this area which is marked T. Anyway, I just shown it because I am having a lot of study material from Plachimada. I had some project staff at that time who were appointed to work on these things and make these drawings. So I just wanted to show that these studies were done on Plachimada area, and the buffer area of the factory in and around is some 2 kilometers we have taken. And you see here, Plachimada area is around here. It is this red color, mostly paddy area. Plachimada was earlier a paddy area. And this is paddy area and this is mixed crop area. So Plachimada comes somewhere here. And this is what I wanted to show you. After the water was extracted from Plachimada, every day 20 lakhs of liters water they were extracting. Plachimada, every day. Once I went to inspect that, I took the government permission and I instructed them that entry should be given to me. I took a team to the Plachimada Coca-Cola factory and I studied how much pumping they were doing. 20 lakhs they were pumping every day. And out of that pumping for 2 to 3 years, the chloride distribution in Plachimada area, if you go now to Plachimada, you can drink only salt water because all the fresh water has been drained off and the chloride concentration has gone to above 500. At that time when I checked it, it was 568 plus. See? And this is the hardness distribution of Plachimada. This core area, you see the hardness has gone to 1000 plus. Normally only industrial waste will have so much hardness. It's not permitted for drinking water. Drinking water hardness has to be well below 250, at the most 300 milligram per liter. This is around 5 to 6 times that. This is the harm which the Coca-Cola company has done to Plachimada. And we studied a new technique for Plachimada. This was given to the people there. We found that this is similar to the Nalgonda technique, which is used for fluoride removal, which was invented by the local people of Nalgonda in Andhra Pradesh. We did similar study, my project team conducted. They found that coconut shell charcoal, it is filled in a pot like this. It can remove the hardness heavily. It can remove this much. The hardness which was 2840 reduced to 300. The chloride which was 961 reduced to 385. The pH which was 8 was improved to 8.42. Anyway, these two, hardness and chloride, could be removed by this treatment technique. Only disadvantage of that technique is every week, twice you have to remove that charcoal. But charcoal they can easily make. Just burn some coconut shells and you can make the charcoal. So many of them practiced it. I don't know whether still they practice it. Yesterday I saw a TV interview which says that the water is so hard and so chloride content that they don't want to drink it now. They are now depending on the water which is brought by the tankers. Anyway, this process can be done even now there. I train this to many of the people there. I don't know whether they are doing it. The next is the Parambikulam Ahalia project. The funny thing in Parambikulam Ahalia is the entire area of Parambikulam Ahalia, around 80% belongs to Kerala. The entire water is taken away by Tamil Nadu. This is the tragedy. They are not giving. Anyway, I just wanted to mention it. I'm not going into details. You see the area. This is the separation line. This line, left of this is Kerala, right of this is Tamil Nadu. The entire water is being taken away to Tamil Nadu. Kerala is getting very less water from the Parambikulam Ahalia project. And this is the Mullaperiyar issue, which is very, very vital in Kerala. Mullaperiyar. Why this is vital? This is a photograph of Mullaperiyar. Why this is vital? This is the shape of Mullaperiyar Dam. I happened to go through some papers published by the experts in that area who studied it. The inside is almost hollow now. Inside was lime surkey concrete. Lime surkey concrete has got a peculiarity. It will dissolve in water over the edge. So now the Mullaperiyar Dam has got this outer shell and this inner thing is fully blank. It can break at any time. But there is one advantage. These are the data of Mullaperiyar Dam. I have conducted, I think once I was invited by a college in Alappuzha district to talk on Mullaperiyar. 2 to 3 hours I gave a long talk. The essence of the talk is this much. If Mullaperiyar breaks in summer, there is no danger because Idukki will have vacancy. Idukki Dam can contain 5 times Mullaperiyar, no problem, in summer. But in rainy season, when the Idukki Dam is filled, in case Mullaperiyar breaks, shatters, then entire Ernakulam district and part of Thrissur and Alappuzha district will be drowned. That is a danger. And Mullaperiyar can break anytime. It has got an outer shell. Just imagine something is having an outer shell only and the inner thing is totally gone. What will happen to it? It will vanish at any time. So Mullaperiyar, that is the fate. And let us hope that it will break only in summer. But tragedy is that mostly dams break at the time of storms. You would have heard about the dam breakage at Gujarat. It broke when the heavy rain was there. If at all at heavy rain time, Mullaperiyar is breaking, this tragedy is going to happen. Idukki Dam will not be able to contain it. All the details I am not discussing now. This is the last project, Adirapalli project. Kerala government is saying it will take it up again. But very dangerous because the Adirapalli project can give you 163 megawatt power. But if the land is taken up, the entire area which you have seen in Bahubali will be lost. That will be drowned. So in addition to that, it's a very sensitive economic zone and fragile environmental zone. That area, I'm not going to the theory. The geology of Adirapalli is very fragile. So Western Ghats in general is that area where most of the rare species are there. So I suggest that don't jump into the Adirapalli project. We can think of substitute projects. So I'm stopping my discussion at this point. I think I finished right in time. But 5 minutes we can spare for any question answer on this so that those who have been listening to my monologue, I don't know whether you have understood properly or not. Those who have been listening to my monologue, they can now ask me something if they want. And obviously, many of the videos which I have published on related matters in the 80s and 90s, some peculiar teams used to come from Bombay, environmental teams, to video record these things. So many of them have recorded so many videos on all these issues, and they have shown, because recently my neighbor's daughter was saying that she is studying at Bombay and she has seen a film which was made in the 90s on water issues of Kerala, where I've been talking for 20-30 minutes. So such things have been done even in the past, even before the social media came. But these are, I just made you aware of the groundwater storage and then what is imminent for us. And obviously, my area of interest was structural engineering. I was not a groundwater specialist, but due to so many projects which I was given by the government and I was given by even for studying Plachimada, state government funded me and some NGOs from Bombay, they funded me. And the study results were taken away by some Norway government also. I don't know what for they wanted this. Anyway, I'm saying that people are interested in such environment related issue all over the globe. Okay, so this is my address totally. It's exactly 8 o'clock now. Maximum 5 minutes. I don't know whether anything is there in the chat box. Nothing, only feedback form is there in the chat box. All of you fill the feedback form because you will get a certificate. That is advantage. Fill the feedback form to get the certificate. Any questions? I don't know how many people listen fully. Nowadays for technical talk.
Regarding the Mullaperiyar, there is two talk. So regarding the Mullaperiyar, there are two ways. Some side says there is no danger, and then you say that it is going to break, it is imminent. But layman like me is kind of confused.
Yes. Every technical hand knows the reality. For example, in 1971, the Mullaperiyar agreement was renewed overnight without even discussing the cabinet. At that time, luckily or unluckily, the chief minister was a very pious person. He was a non-corrupt person. So he was not corrupt. But he has been forced into signing it, threatening the existence of the ministry. I'm not supposed to reveal those things. I know it. So the Mullaperiyar agreement was renewed under threat. Nobody would have renewed it, which is who will put that into danger? Even now, what the Tamil Nadu government is saying, they can construct a new dam. They are not ready to spend for it. That means that is a value they give to the people of Kerala. Anyway, Supreme Court, even courts are being now influenced. I am not going into that legalities. The reality is that if Mullaperiyar breaks in rainy season, around 20 lakhs people will be affected. Many thousands of people may be drowned also. It is high time that a replacement dam is constructed. Or else, I think when the tolerance limit is over, somebody will break it in summer without any risk. Between Mullaperiyar and Idukki Dam, there is a distance of around 30 kilometers. That is forest area. Inhabitation is very less. So, if the water of Mullaperiyar is contained in Idukki Dam, absolutely no risk. That will not happen in rainy season. Even Idukki last time was full. Even otherwise, it will be near full. So, all the engineers and technicians know what is the reality. The technologists know. And they are not hiding also. They speak out. But political decisions take prominence. And Tamil Nadu government and Tamil Nadu people are very clever in such deals. They know how to make the deal. And if the speech is given to them, maybe they may outcast me also. True. We are having some colleagues from Tamil Nadu. Definitely, Mullaperiyar is of interest to them because they are getting most of the, 3-4 districts are getting water from Mullaperiyar for agriculture. I have nothing against giving them water, but why can't they make a new dam? Let the existing dam be there. Downstream, they can make a new dam so that there is no risk for the Keralites. That should be done. This is my technical advice on the matter. Otherwise, the unwanted may happen. Sometimes some lunatic will break it. So for any individual, their own life is more important than some other state's agriculture. Okay. Any other questions?
Sir, like Tamil Nadu government, is there any, sir, is it audible, sir?
Yes. Yes, it's
Sir,
audible.
is like Tamil Nadu government, is there any compulsion that we should have rainwater harvesting systems when we build a house in Kerala? In Tamil Nadu, it is compulsory.
Yes,
compulsory.
yes, in Kerala, it is now compulsory. The last revision of the Kerala Municipal Building Rules and Panchayat Building Rules, it is made compulsory. To get an approval for construction, you should have rainwater harvesting system. But nowadays, house construction is very less in Kerala. Kerala is having excess stock of house. Kerala needs only around 80 lakhs houses. Right now, 89 lakhs houses are there in Kerala. That means around 10 lakhs houses are unused. So the new houses are going to be very less. Kerala is the only place in the world where around 15% of the houses are locked up, unused. So the housing stock is much more. 3 years back, we had a discussion at the State Planning Board. I was also there in that committee. And we were discussing what to do with these houses. Closed houses. Around 10 lakhs are there in Kerala. It's the only case in the world. Can the government break it open? Owner will be in USA or Canada, but the houses here closed. It's a peculiar developmental model.
Thank you, sir, for the wonderful session.
Thank you. Thank you. Someone else is talking but not audible. Who said I am unable to see the
Who said I am unable
India,
to see
Yuva?
India, Yuva?
Not heard. No voice. You can put in the chat box if you.
Sir, I think it is from the India Yuva Chopal News, right? I think he was the one who was speaking.
But sound is not coming. No more questions. We'll wind up then, because
No more questions. We'll wind up then, because
you
you have been patiently
listening.
You have been patiently listening.
Let me see the chat box. Any questions there?
Let me see the
No,
chat
nothing
box.
is there in the chat box. Okay.
So we'll move on to the vote of thanks part. I invite Dr. Mahima Ganeshan, the President of Institutional Innovation Council of Ahalia School of Engineering Technology.
Thank you, ma'am. It gives me sheer pleasure to offer vote of thanks on the occasion of World Water Day. On behalf of my college and management, I thank our renowned resource person, Dr. P.R. Sri Mahadevan Pillai, for sharing his knowledge and tremendous experience in the field of water conservation. Next, I thank our Vice Principal, Dr. Krishna Kumar Kishore, for his continued support. I am thankful to all the department HODs, my dear colleagues, students, and all the external participants for their active participation in this event. I highly appreciate our beloved EEE HOD, Dr. Muruganathan sir, for the presidential address, and Professor Lakshmi Suresh for her heartwarming welcome speech. I thank Bindu Valu madam, who's always active in organizing and implementing all the occasions. Her energy and enthusiasm is highly appreciated. We are expecting this wholehearted support in forthcoming events as well. Thank you all.
Thank you, ma'am. So I think we'll call it a day.
So good night to all of you. Good night.
Good night.
Thank you, sir. Okay.
Yes, sir.